Yes, it's Uncle Jegz. Today will be the last of the combined science required practical.
No, please, don't leave me.
You can click the card here to take you to the playlist that shows all the required practicals that we've gone through. In this video, we'll be going through 3 different types of electromagnetic waves. We'll then be looking at the uses of those electromagnetic waves, and then finally we'll jump into the radiation and absorption required practical. Well then, let's chop some science. Here are the retrieval questions for this lesson. You know what to do. Wave speed is equal to frequency times wavelength. Radio waves have the longest wavelengths, and the speed of light is 300 million meters per second. We will be focusing on EM waves in the context of radiation and absorption. I'll quickly go over some background information to help us with this. EM waves are electromagnetic waves. This means that they have both an electrical side and a magnetic side. They are also transverse waves. This means that they vibrate, they oscillate at 90 degrees to the direction of the wave. This is different from longitudinal waves, which vibrate, they oscillate in the same direction as the wave. EM waves are able to travel through the vacuum of space, which is why we can see light from distant galaxies that existed billions of years ago. More on that in a future video. Let's look at some of the uses of these waves. Radio waves, oddly enough, are used to carry radio signals, TV signals, and also mobile phone signals. Microwaves, not surprisingly, are used in microwave ovens, and they're also used in 5G communications. Check out my video on 5G waves to see more details on that. And finally, infrared radiation is used in remote control handsets and infrared scanners that are used to check people's body temperature. If you are a higher student, you also need to understand these additional properties.
You don't know nothing, but I'm gonna tell you something. You know what I'm saying?
When a wave encounters a boundary, it can be absorbed. This just means that the energy is taken in by the object. The wave can also be transmitted, which means that it can pass through the object. This is like the light that enters through your window. The wave can be reflected, which is like what you see when you hold a mirror or a body of water to yourself. You can see your reflection. Or it can be refracted. And as you can see here, different liquids cause different levels of refraction. The reason why this happens is due to a change of the speed of light as it travels from one medium to another medium at an angle. Here we see a wave moving from air into glass. Also notice that it's moving at an angle. The reason why this is important is because these lines here, which are the wave fronts, don't hit the boundary at the same time. Since it's moving at an angle, we notice that part of the wavefront hits the boundary before the rest of it. And since the speed of the wave touching the glass is slowed, the rest of the wave will be moving faster than this portion here. And as more of the wavefront touches the boundary, the wave starts to change direction. To help you understand this concept, imagine that the air is the grass here, and that the glass is the mud. The wavefront can be represented with this rolling pin. When it goes at an angle, the part of the rolling pin that hits the mud slows down. This corresponds to the part of the wavefront that's hitting the glass. As the part of the rolling pin on the grass is still moving at its normal speed, the whole of the rolling pin will start to turn towards the new medium, which is the mud in our example. This is what's happening with the wavefront in the air. They are moving at the normal speed in the air, but they start to turn towards the glass because some of the wavefront is hitting the boundary, which is the glass. I know you're loving these amazing animations. I do my best.
Sensational.
So how does this relate to the required practical, you may ask me? The aim of the investigation is to investigate the amount of infrared radiation that radiates from different surfaces. The dependent variable, which is what you're measuring, is the infrared radiation. Infrared radiation is what we feel as heat. So when you put your hand next to the radiator but you're not touching the radiator, the heat that you're feeling, that is infrared radiation. And some organisms like snakes, the reason why they can track you in the night isn't just the smell particles, but they can actually sense the infrared radiation. It's EM waves, just like light. So they're basically seeing you in the dark because of the heat that you're giving off. What we're changing, the dependent variable, is the different surfaces. You will need a kettle.
Well, you can at least put the kettle on.
An infrared detector or a thermometer if you ain't got that to hand, a heat-proof mat, a ruler, and one of these things called the Leslie cube. The Leslie cube has different surfaces on it, so each side has a different surface. You've got an opening on the top that allows you to pour hot water inside it. These are the steps. It's actually a pretty simple experiment. First thing, you place the Leslie cube on a heat-proof mat. Then you fill up the cube with hot water that you get from the kettle, and then you apply the lid straight away. Use a ruler to position your infrared detector 5 centimeters away from the surface that you're measuring. Then you record your highest temperature, and you do the same for each surface, making sure that your infrared detector or your thermometer is always 5 centimeters away, or whatever distance that you decide. Once you're done, you should have a table of results that looks something like this. Notice how the best radiator was matte black. That's why when you look at teapots, they're never matte black, because if they were matte black, they'll be cooling very quickly because the heat energy is radiating out. Okay, that's why they're usually very light and very shiny, so because they're very poor radiators of heat. And also you can think of it this way as well, the surfaces on the road, when it's very hot, it's usually the darker parts that feels the hottest because it's radiating a lot of heat. Using your results table, you can graph your results. Your independent variable, the surface, it will go on your x-axis, and your dependent variable, what you measured, which is the temperature, will go on your y-axis. And obviously we will not be drawing a line graph, we'll be drawing a bar chart because our variables are not continuous. The surface is not a continuous variable. And there we go. Lesson done.
Fatality.
I hope you found all of that useful. Check out the descriptions below if you want to check out some goodies that I've made, and make sure you click on some of these playlists. We've already done biology, so the required practicals are done now. I've done some calculations in chemistry as well, so check those out if you need more help. More videos are coming every single week. Working. I'll catch you guys in a bit.